All right, I have 11:15. Today we are going to more slowly go through something that I did kind of in a rush last Friday. Motivation being if you want your robot to do something at certain intervals or after a certain amount of time, okay, and you're not allowed to use, for example, there's an Arduino function that measures elapsed time since the program has started. In theory, you could just use delays, but you probably don't want to hang up the rest of your program, even though you can use interrupts to interrupt delay. How could you make something happen every second, or say after 10 seconds, without any delays? That's where we're going today. So, some of this is going to be a recap of what we did last Friday. There we go. Friday, but again, I want to go through this a little slower. So far, we have looked at how a timer behaves in normal mode, where we have the timer value on the y-axis, and then either clock ticks or nanoseconds on the x-axis, where remember there's a conversion factor between those, where one clock tick equals 62.5 nanoseconds. There is going to be some, if you just turn the timer on and let it count up, like a stopwatch, there is going to be some maximum value that it counts up to, and then it's going to overflow back to 0. Okay, so that's what we demonstrated in Tinkercad already. And depending on whether it's an 8 or 16-bit timer, that max value is going to be either 2 to the 8 minus 1, so it's going to be 255 for an 8-bit timer, or it's going to be 2 to the 16th minus 1, which I think is 65,535. I might not have jotted that down in my notes, so don't quote me on that number. But I am pretty sure. Anybody have that written down from last time? Did I get that right from memory? 65,535? Yes, okay. For 16-bit, okay? So, based on those max values, I could, and the clock ticks in nanoseconds, I could figure out, okay, how long is it going to take to overflow? How many nanoseconds or convert to seconds is this? But what if I want to change that? What if I want to control this? Okay, how long it takes to overflow? To do that, instead of normal mode, I'm going to use clear timer on compare, or CTC mode, which basically does the same thing, except it lets me pick what value I want the timer to reset to 0 at. Okay? So I still have whatever my max value is. I'm going to stick with the 16-bit example here, although the same concept applies to the 8-bit timers. So I have this max value of 65,535, but I can choose some value lower than that. That is my output compare value, and that is going to be stored in the OCR1A register. That is specific for timer 1. Okay, remember the ATmega 328P has 3 timers, timers 0, 1, and 2. Okay, so if I was going to do this with timer 0, that would be OCR0A, and it has a different page in the datasheet, okay? For 16-bit timer 1, it's OCR1A. So I get to pick that value, and now the timer is only going to count up to that value and reset. So it's not reaching the max value that can be stored in a 16-bit integer. Okay, it's resetting at some value before that. Okay, so you can probably see how by moving this value up and down, I can change the width of the period before it resets, right? I guess I'll draw this in a different color. If I move that down, if I pick a lower OCR1A value, then it's going to reset more frequently. That period is going to shrink. Okay, draw that the whole way across. Okay. I can calculate that period, call that a period T, that it takes to reset. T in nanoseconds equals OCR1A, so the decimal value of that register plus 1. Decimal value of the register plus 1 times the prescaler, which remember can be 1, 8, 64, 256, or 1024. There are only certain values that the prescaler can have, times 62.5 nanoseconds for the period in nanoseconds of 1 clock tick. Okay, so if I have a given or desired period, I want something to happen every second or every half a second, every quarter second, whatever it is. I know the clock ticks. Technically, I have one equation with 2 unknowns, right? OCR1A is an unknown value, and prescaler is an unknown value, but I only have a few specific values available for the prescaler. Okay, so you can just pick a prescaler value. Step 1, pick a prescaler value. So sorry, this got a little out of order, but for a desired period, pick a prescaler value, solve for OCR1A, make sure OCR1A is less than 65,000, or less than or equal to 65,535. Okay, so it's still a 16-bit timer. That's the max value. If you pick a prescaler, solve this, and get OCR1A has to equal 100,000 for this to work, then that's saying, oh, OCR1A would have to go above that dashed line, which it can't do. Okay, so the overflow concept still applies. This only works for OCR1A values less than 65,535. So for, I'm going to run out of room in the coordinate on here. If not, choose larger prescaler and try again. Okay, so remember, the prescaler slows the timer down, makes it only go up every 8 clock ticks instead of every 1 clock tick or every 64 clock ticks. So basically, if I keep the prescaler at 1 and try to solve this and say, oh, OCR1A would have to be 1,000,000, it would have to go way past that line, then that's way too, my prescaler is too small. Okay, so I increase the prescaler and try again. So that's how you deal with this. Okay, technically I have one equation and 2 unknowns. Okay, given that, if the prescaler is 1024, so assume the prescaler is 1024, what should the value of OCR1A be for a timer interrupt period of exactly 1 second? I have this as an open-ended poll everywhere, where I finally checked the right box, so you can only respond once and you can't change your answer. Okay, so we're not going to get, I'm not going to do the word cloud, but we shouldn't get 1,000,000 votes for LeBron. I want you to type serious answers in for this, okay? So figure out what the value of OCR1A would have to be for a timer interrupt period of exactly 1 second. Okay? That is, should be live on poll everywhere. Okay. We had a couple people come in late. But I am going to give that maybe 10 seconds for people to finish typing in replies. 5, 4, 3, 2, 1. Deactivate. Okay. I am going to check. Just glancing at the responses here. Okay, the response history, here we go. Okay, I am seeing a lot of the correct answer, which is 15,624. I'm going to go ahead and just work that out real quick so you have it. So this just comes from this equation. Okay, I have my desired period of 1 second, which is 1 times 10 to the 9 nanoseconds. I don't know OCR1A. Don't forget this plus 1. I think some people typed in maybe 15,625 because you forgot the plus 1 in that equation. I'll skip all the guess and check and tell you that for this, you needed to go up to the max prescaler of 1024. So if you try the smaller prescaler, it wasn't going to work, times 62.5 nanoseconds. And if you solve that, unless I screwed up, you should get 15,624 for OCR1A. So this is an important point to point out that in a minute, we are going to switch over to Tinkercad. We've talked a couple times how it's okay to actually assign register values in decimal as opposed to in binary. This is an example where it's much easier to do that in decimal. It is valid to just write OCR1A equals 15,624. I don't have to first figure out what the binary value of that is going to be and convert it to binary. I can just write OCR1A equals 15,624. Okay? One more poll everywhere I'm going to launch. I do not want you to answer the poll everywhere, okay, but I do want you to work this out. Do not answer this question. If the prescaler is 1024, what should OCR1A be for a timer interrupt period of 10 seconds? Okay, so that was the first question. What about timer period of 10 seconds. And either what should OCR1A be, or hint, is it possible? Can I actually do that? Can I get a timer interrupt period of 10 seconds? Yes, in the back.
For all these questions, if you don't mention the internal clock, do we always assume 16 megahertz?
Yes, for the H that is specific to this microcontroller. Okay, if you switch to a different platform, you cannot assume that. I believe there may also be some either internal settings that let you select a different clock frequency, or one of the pins will select an external, will let you use an external clock from a function generator. But we are always assuming that 62.5 nanosecond. For everything we're doing in this course, you assume the 16 megahertz clock frequency, which gives you the 62.5 nanosecond clock period. Okay? Okay, can anyone just tell me the answer to this one yet? You made eye contact, I'm just going to call on you. Do you have something?
Yeah, I got 156,249, so not possible.
Not possible, okay. So I can't actually do this, okay? Going back here, having a timer interrupt period of 10 seconds would require that the output compare value be like off the charts here, okay? So we are going to switch over to Tinkercad and talk about, okay, well, how could we do that? And I think if you do the math, the maximum period you can get with the maximum freescaler is somewhere around 4 seconds. Okay, so if you want to measure something or have some elapsed time, roughly about 4 seconds or less, that's easy. And it gets you can do more than that, but it gets a little trickier. Okay, so we are going to switch over to Tinkercad. Laptop. It would help if I plug the HDMI cable in. Okay, as we have before, you can just start a new Tinkercad circuit or copy over an old one. Make sure you don't overwrite useful stuff that you already have. Okay, I'm not even going to worry about connecting anything to the breadboard yet. I'm going to go to my code, switch to text. Okay, and again, we kind of did this before, but I was going really fast, so I'm going to actually zoom in on the code. Maybe? There we go. All right. Delete that. Set up the structure we're going to want for a program with a timer interrupt. Okay, so we're going to have an ISR. I'm just going to tell you without having to, you would go look this up in the interrupt vector table. We want timer1 underscore comp A underscore vec. So again, these interrupts also exist for timer 0 and 2. We're using timer 1, so you could go look up the interrupt vector table and look up what this vector argument would be for the timer you're using. Okay, I'm not going to throw anything in there yet. We have our main function, int main void, and our while loop. Okay, length kind of skeleton program. There we go. No. Square bracket instead of curly bracket. All right. First order of business is we want to, in the main function here, set timer1 to clear timer on compare CTC mode with prescaler of 1024. Okay, so we have TCCR1A and TCCR1B. Okay, I want you to do that part because you are going to need to get comfortable looking up stuff in the datasheet for the timers for your robot, because you're now going to be using multiple timers for different things. Okay, so go over to the ATmega 328P datasheet. Pull up, I believe it is page 170, not 1070, where these registers start. Okay, so we looked at this a couple times now. We have TCC R1A, which has some of our waveform generation mode bits in it. We have TCC R1B, which has the rest of the waveform generation mode bits and the clock select bits in it. And then you have two tables. Okay, we have the waveform generation mode table, where you see one of these modes is CTC for clear timer on compare. Okay, and you have the clock select bit table that tells you what these bits need to be to select different prescalers. Okay, so go to datasheet 170. Values for WGM and CS bits. Okay, and assign the values for the TCC timer control registers. Okay, anybody totally stuck or unsure how to do this? Again, I don't want you to just sit there and have no idea what you're doing, because you're going to need to do this. Okay, is that a question or just totally stuck?
What do you want the bits like to be like referring to?
That is what you need to look up in the data sheet.
No.
Okay? But so remember, hold on. These bits these are not our I/O registers, so these don't correspond. These have nothing to do with physical pins, if that's your confusion. Okay? These timer bits are controlling different things about how the timer operates. Okay, so each one of these bits has a description that you can read in the datasheet if you want kind of the whole paragraph, but I'm telling you that the ones I want, you can ignore these other ones we're not talking about. There are two sets we care about. The clock select bits, set the prescaler. Okay, so this table gives you values for what you need to set. So if I want to set the prescaler to 64, which isn't what we're doing for this problem, but these three values are what I would select those clock select bits to. And if I want to set it to CTC mode, I need to set the WGM bits to these four values. Everything else you just leave as 0. Okay, the default values are 0. If we're not talking about it or I didn't tell you to change it, you just leave it as 0, but you need to look up which bits are set to 1 in these tables. Okay? Other questions that are like, not even sure how to go about starting this? Yep.
There's two different CTCs.
Good point. I did not look down far enough to notice that one. So, two different CTCs in this table. See how this one says top is OCR1A? So that's going to store that maximum value in that OCR1A register. This one says top is a different register, ICR1, and I would need to look up what exactly the deal with that register is. So ignore mode 12, use mode 4. Okay, I would need to go check in the data sheet what exactly ICR1, or how ICR1 is different from OCR1A. Okay, I am gonna keep moving here because we're actually gonna end a little bit early today because I need to get over to a talk in Upson. It turns out TCAC R1A is just all zeros. You don't actually need to wind up changing any of the bits there. So 1, 2, 3, 4, 5, 6, 7, 8. And looking up the correct values for TCC R1B gives 1, 2, 3, 4, 1, 1, 0, 1. And again, that's a mix of the clock select bits for these two different things, the waveform generation mode and CS. Okay. We've turned it on in clear timer on compare mode, but we need to do two more things if we want that interrupt to fire. We need to tell it the OCR1A value we want. Okay, so OCR1A, we're just going to write that equal to the value we calculated before, 15,625. Okay, again, don't have to write that out in binary. We also need to enable the interrupt using a register just like we did for pin change and external interrupts. And I should have, but forgot to look up what page this one is on. This one is called, nope. Okay, so there's that ICR1. Again, I would need to look up exactly what that one does. Out compare. Okay, the register is called TIMSK1. There we go. TIMSK1. Okay, again, there's a bunch of bits here. We don't care about what all of them do. You can read the description in the data sheet. We are using output compare A, okay, which corresponds to that OCR1A register. So we need to set this bit here, OCIEA or OC1EA, depending on the font they chose. We need to set that to 1 to turn this interrupt on. Okay? So to do that, I'm going to write TIMSK1 equals, there will be 1, 2, 3, 4, 5, 6, 1, 0. Okay, so that has enabled this interrupt, so this interrupt service routine will now fire. Need to do one more thing, which is what I forgot to do last time. I see your hand, I'll get there in a second. Don't forget that SEI command. You always need that for interrupts, whether it's a pin change interrupt, timer interrupt, any other type of interrupt. Without SEI, even if you set up all the registers right, the interrupt won't work. Question?
Should it be 15,624?
Yep, because I messed up writing that down. Thank you. Okay? So, I'm now going to initialize serial communication. Say something serial begin 9600. And then inside my interrupts, I'm just going to put a, say, serial print, I don't know, it's been 1 second. Whatever you want to type there. Okay? Assuming I did not screw something up this time. Where'd my mouse go? There we go. Start simulation. Nope. Timer 1. What are you? Oh, I did not end that in a semicolon. Try again. Put the serial monitor. Okay, great. It's just printing a message once every second. Okay. Questions or anybody? Again, I don't want to go faster than people can keep up. Anybody not have that working or get stuck on something? Again, save this as your timer interrupt, and that way you just have this as reference when you're working on the project. Okay, the more tricky part is, okay, what if I want something to happen every 10 seconds, right? But I can't actually get my output compare value big enough to make that happen. I can use a counter variable that I increment in the vector, and then, sorry, in the interrupt service routine, and then only do something when that counter variable has reached 10 or 100 or whatever. So if I say, I'm going to do unsigned int seconds equals 0, I'm just going to start some seconds counter at 0, and inside ISR, seconds equals seconds plus 1. You can also write seconds plus plus, that's C shorthand for just incrementing the variable by 1. Okay, and then have an if statement, say if seconds equals 10. Then I'm going to print. It's been 10 seconds. And there I'm also going to reset seconds to 0. Okay, so now even though that, again, the maximum time I could get with timer 1 and the maximum freescaler and everything is around 4 seconds, this lets me track an arbitrary amount of time. Yes?
What's the difference between serial.println versus serial.print?
Serial.println makes it print on a new line. So if you don't do that, it'll just keep printing horizontally forever and makes it really annoying to read.
Thank you.
So if you want to print multiple things on one line, then you can use serial print multiple times and say, like, if you want to print some text, like x is equal to something, and print it on one line, you can use multiple serial print commands and then end with a println to print on a new line. Okay? So now, again, unless I screwed that up, it should print 10 of those and then kind of do a double. It's been 1 second and it's been 10 seconds. So there's the 10 seconds. Okay, and there was a little weird, oh, because I intended to put an ln there and just messed it up. But you see how it printed both of those on the same line. Okay. Okay, so again, save this if you want your robot to do something halfway through the match or do something every 5 seconds. It's only a 1 minute match, right? So this isn't a question of measuring elapsed time. And again, speaking of measuring elapsed time though, if you do want to measure longer periods of time, talking about hours or days, that's where you do need to start thinking about data types again, because this seconds variable will eventually overflow, right? If it's an unsigned int and it can go up to 65,500, whatever, well, you can't, this method would not measure more than about 65,000 seconds, right? So if you want to measure, again, hours, days, weeks, or something, you would need to think of different variable types and look at what the max value is, or only increment it every 60 seconds. Excuse me, what's my voice? Every 60 seconds or something, right? So you're measuring minutes. Okay, questions on that?
Is the content in the process after the IS gone matter?
This here? Yes, this comes from, there's a document on Canvas, so get vector from interrupt vector table on Canvas. That map quantity in the parentheses tells the program which interrupt service routine this is. So when we did pin change and external interrupts, there was a different value that went in there. Okay, so even if you set up all your registers right, if you have the wrong thing in parentheses there, this interrupt service routine isn't going to work like you want it to. Okay? Other questions on this? All right, we are going to do 2 quick things, kind of miscellaneous items with the end of lecture then, and we're actually going to end a little early because, again, I want to get to a talk in opposite at noon. First, in my ongoing attempt to make sure people are being honest with poll everywhere, please do answer this one. Just answer C. Okay, this is not a real question, just answer C. And then we are going to talk about a robot project question that I got at the very end of lecture last time and kind of had to give some thought to and double check the rules before I could figure out if it was going to be allowed. This is the net question for those of you who asked about the net last time, but I'm going to do this first. So please answer C to this question. Okay, 5, 4, 3, 2, wait a second. Oh, are we having poll everywhere login trouble? Okay, good. 5, 4, 3, 2, 1, deactivates. Okay, and switching back to the document cam real quick. I got a question at the end of lecture last time about whether your robot can use a net, given the language that I had about the perimeter of the robot needing to be a structural or mechanical element. Does that mean it needs to be rigid? So here's kind of the determination based on my reading and adjustment of the rules. Basically, it is okay to use a net if it stays within that 12-inch diameter cylinder and stays attached to your robot. Okay, so if here's the robot, and you kind of have a net like this, that is okay. If it is still attached to your robot somehow and is being used to gather the cubes, okay, that's kind of different from the umbrella scenario where you just have an umbrella going across the top that isn't actually gathering the cubes. What you cannot do is basically just build a catapult that launches a net at the beginning. Okay, so if your robot's here and the cubes are kind of scattered in the middle and you just like launch a net and say, oh, well, that's in the perimeter of my robot, even if the net stays tethered to the robot, right? So if you have a string and you're kind of casting the net, that would violate the 12-inch circumference rule. Okay, so cool idea, but that would kind of get away from the idea of the competition where I do want you to actually program a mobile robot and not just build a catapult. So I know no matter how hard we try to come up with all the rules this year, there's always some sort of loophole, so that was a good one. Again, that's not to say this is a good idea. It may or may not be. You know, I could imagine some robot that either deploys multiple nets to the sides or like one kind of radial net to grab the cubes. Again, as long as it is a structure that is contributing to gathering the cubes and not just kind of saying, oh, I'm above the cubes or covering them, that is okay. Again, your net may get entangled with the other robot as long as it is not causing permanent damage somehow and can be untangled. That is also okay. So again, that was just a specific question I got from one team at the end of lecture last time. So let me check. We got a couple minutes for other reminders. I did just publish the project rules. So I had not published them Monday because I needed to finalize a few things with the lab staff. The part order vendors and dates are not finalized yet, so you can definitely count on McMaster and DigiKey, but the dates and number of orders I'm not sure about yet. And last year's rules did say 3D printing was allowed in the RPL, so I need to confirm if that is correct, and we'll try to have it. We'll definitely have that finalized before spring break. That may have changed since I taught in 2021, but it was only laser cutting. So if you read it and see there are a few little things that are still to be determined, all that should be finalized before spring break. We are also going to go with 4 open lab slots since that got the majority of votes, meaning 4 slots per day. Every team can sign up for 4 per week. It doesn't have to be on the same day or same time. And I will add 1 in that kind of 4:30 to 7:30 window, and then 1 probably from 8 to 10 or so to kind of give flexibility with scheduling. So again, like 2 more minutes, robot project questions based on stuff from last time or so far. Yes?
Can you detach objects from your robot with the intention of trapping the other robot?
Yes. So that is, I'm not going to pull the rules up now, but there is a rule somewhere that says objects detached or dropped from the robot do not have to adhere to this 12-inch diameter rule, but they cannot contribute to gathering the cubes. Okay, so again, if you're trying to trick or trap or whatever the other robot, again, with the caveat that no permanent damage to the other robot or the board. Like we had a team one year who wanted to put tape down on the board, and eventually we ruled that out because of the sticky residue it could leave behind. So if you want to drop things that are not contributing to gathering the cubes but intended to interfere with the other robot, yes, that is okay. Okay? Other questions? Okay, again, I need to get over to talking to Upson in 5 minutes, so I will kind of be here for questions as I'm packing up, but I'm going to head out a little quicker than usual today. I will see you on Friday.